Welcome. Today, we're diving into the digital transformation of cleanroom pressure management. I'm Dr. S.K. Singh, and together we'll explore how technology is reshaping this critical aspect of cleanroom operations. Let's uncover the innovations driving precision and control in these highly sensitive environments. Let's talk about why digital transformation is essential, especially when it comes to pressure monitoring. Traditional systems rely heavily on manual recording, which means data is only captured periodically, causing delays in response. This approach limits our ability to see trends and opens the door to human error. On top of that, regulations are getting tougher, demanding continuous monitoring and stronger data integrity. Digital transformation changes the game, offering real-time monitoring, automated alerts, predictive analytics, and better compliance. It's about making smarter decisions faster. Our journey toward Pharma 4 unfolds in clear phases. We start with manual monitoring, mechanical gauges and paper logbooks, simple but limited. Then we move to electronic monitoring, using digital sensors and electronic records for better accuracy. Next comes integrated monitoring, where building management systems connect to centralized dashboards. Finally, we reach intelligent cleanrooms, powered by AI, machine learning, predictive analytics, and digital twins. The future. Autonomous systems that self-adjust cleanroom pressure, taking control to a whole new level. Let's break down the architecture behind digital pressure monitoring within a smart environmental ecosystem. At the base, we have sensors measuring pressure differences, airflow, temperature, and humidity. These feed data into the second layer, where systems like building management and SCADA collect and organize the information. Next, the analytics platform digs deeper, spotting trends, modeling patterns, and using AI to predict what's coming. Finally, the decision support layer turns insights into action, triggering alarms, suggesting corrective steps, and scheduling maintenance to keep everything running smoothly. We're looking at a centralized dashboard that updates every 30 seconds, giving us immediate visibility into environmental conditions. This means we can see pressure differences across areas like grade B, C, and D in real time. The dashboard tracks key features, pressure differentials, cascades, alarm status, historical trends, and HVAC performance. For example, a sterile filling facility uses this live monitoring to ensure everything stays within strict parameters, keeping the environment safe and compliant at all times. Let's talk about automated alarm management and how smart alarm systems keep us ahead of potential issues. We set alert levels based on pressure differentials. For example, under 12 pascals triggers an alert, and under 10 pascals demands action. When pressure drops from 15 to 11 pascals, the system doesn't wait. It immediately generates an alert, escalates the issue to engineering, and logs everything for review. Notifications come through SMS, email, mobile apps, and building management systems, keeping everyone informed and ready to respond. Let's talk about how predictive analytics and AI are changing the game. Instead of just reacting to problems, we're moving toward predicting them before they happen. AI looks at environmental data like pressure trends, temperature, and humidity. It also monitors equipment details, fan speed, filter loading, damper positions. For example, if AI notices pressure dropping steadily, it can predict when it'll hit a critical limit. That means we can step in early, preventing issues before they even start. Let's talk about digital twins and how they transform cleanroom pressure management. A digital twin is a virtual copy of the cleanroom, constantly updated with real-time data. It simulates key factors like pressure cascades, airflow patterns, HVAC performance, and even the effects of opening doors. For example, before changing a production room layout, engineers use the digital twin to test airflow and ensure pressure stays balanced. This approach cuts design risks, speeds up decisions, and helps optimize the entire facility. Let's look at how integration with the contamination control strategy works in practice. The system spots a clear pattern. When the pressure differential drops below 10 pascals, particle counts jump by 40%, followed by an increase in microbial recoveries within 1 to 2 days. This insight leads to revising pressure limits, strengthening the overall contamination control. The digital framework pulls data from pressure, particle, and microbial monitoring, plus HVAC performance. It then generates risk scores, trend reports, predicts excursions, and suggests corrective actions. This is how data drives smarter contamination control. When we talk about data integrity and compliance, we're really focusing on trust, making sure data is reliable and meets strict standards. ALCOA Plus is a key framework here. Data must be attributable, legible, contemporaneous, original, and accurate. For example, every pressure alarm automatically logs the date, time, user response, and investigation status. On top of that, regulations like EU GMP Annex 11 require computerized systems to be validated, secure, and traceable. Meanwhile, FDA 21 CFR Part 11 demands audit trails, user authentication, and electronic signatures. Together, these rules keep data honest and compliant. Smart maintenance is all about working smarter, not harder. With predictive maintenance, digital systems keep a constant eye on key components, like HVAC parts, HEPA filters, fans, dampers, and pressure transmitters. For example, AI can spot rising pressure losses in HEPA filters and predict when a replacement is needed, say, within 2 weeks. This approach cuts downtime, boosts reliability, minimizes environmental hiccups, and lowers maintenance costs. It's a clear win for operational excellence. When it comes to regulatory expectations, there are several key requirements we need to keep front and center. Continuous monitoring is essential, along with strict data integrity compliance. Risk-based environmental control helps us focus where it matters most. Validated computerized systems and their integration into the control and compliance system are critical. Plus, periodic review and performance verification ensure everything stays on track. Looking ahead, the future of digital pressure management is exciting. Emerging technologies like artificial intelligence, machine learning, digital twins, and cloud-based monitoring are transforming the landscape. We're also seeing the rise of IoT, autonomous HVAC systems, and continuous process verification, all driving smarter, more reliable operations. We're at a turning point in cleanroom pressure management. Digital transformation is changing the game for contamination control in pharmaceutical manufacturing. By bringing together real-time monitoring, smart analytics, predictive maintenance, digital twins, and AI-driven decisions, companies can tighten environmental control, boost efficiency, and stay ahead of regulations. As Pharma 4 grows, digital pressure management will be the backbone of smart cleanrooms, helping prevent contamination, verify processes continuously, and drive sustainable excellence. The benefits: better product quality, faster operations, and stronger compliance. That brings us to the end. For any further support, please don't hesitate to reach out. Thank you for your time and attention. It's been a pleasure sharing this with you. This video was created with SlideSpeak. Visit SlideSpeak to turn your presentations into engaging AI-narrated videos.